Hello and welcome. So in this session, we are going to do a hands-on exercise with broadcast variables in Spark. So in the last session, we already saw what broadcast variables are. We saw how Spark optimizes the transfer of broadcast variables to different executors. In this session, let's jump into a hands-on exercise. So the use case that I have brought is actually a real-life use case. Basically, it's a use case from Telecom world. In telecom world, there is something called a tag ID, which is basically an ID that belongs to every device model, right? And there is something called a tag database. A tag database is nothing but a mapping of every tag ID with the manufacturer of that device and the actual model of that device. So I have some real data here. If you look at this data set, the first column is the tag ID, and then the second column is the manufacturer of that device, and third column is the model of that device, right? So this file contains some 25,000 entries, where almost every tag ID that exists in the world is present in this file. So there are about 25 to 26,000 different mobile models available, and corresponding to every tag ID, you have the device manufacturer and the device model. If you see, there are multiple tag IDs that belong to the same manufacturer, right? And there can be multiple tag IDs belonging to the same device model as well. The second data set that we have is call drops. So this data set is basically all about number of calls that are being dropped on a particular tag ID, right? So for example, on 1st of January, for this particular tag ID, there were 17,590 calls that got dropped, right? So similarly, you have such call drop counts for many tag IDs across many days. Okay, so the number of records in this file, if we see, are about 259K. Okay, so the use case that we are going to solve is that we want to figure out which are the devices that are performing the worst. Basically, which devices are, resulting in maximum number of call drops. Now, if I just aggregate this second data from this second file based on the tag ID, then probably that will not give me very good information, right? Because tag ID is something that's not human readable. I mean, you're not going to make out anything out, even if you get like total number of call drops per tag ID. So my target is that I want to join these two data sets in a way that I should get which devices are dropping maximum number of calls. For the sake of simplicity, we'll figure out which manufacturers have maximum number of call drops, right? So which means for every tag ID in this file, I will have to look up what's the manufacturer for that particular tag ID from this file. And then corresponding to that manufacturer, I'll add all the number of call drops. And finally, I'll sort them and figure out which are the worst performing manufacturers. All right. So let's solve this problem using Spark. And this is the use case where we are going to make use of broadcast variables as well. So let's look at the code. Right. So here is the code. Let me explain it line by line. In the initial part, we are just importing some packages, and then we have our main function. We are just setting the log level here, and then we are creating a Spark context. This is where the actual logic starts. So what I'm doing here is I'm creating a map in Scala, okay, which is a mapping from string to string. Then I'm reading the tag db file. In this statement, I'm reading the tag db file, and then I am iterating in that file line by line. And what I'm doing is I am splitting that line, every line on comma, okay, and then I am inserting the contents of that line into the tag db map. Basically, I am creating a mapping of tag ID, which is column 0, to the manufacturer, which is column 1. So after this for loop, I will have a copy of a map, basically a hash map, which contains mapping from tag ID to the manufacturer, right? So far, nothing is basically in the context of Spark. Everything is in the context of Scala. So we have this hash map available at this moment. Now what we want to do is, because a call drops data is going to be partitioned across different executors and tasks, right? In the Spark cluster, we want this map to be available to all the executors so that different executors can annotate the manufacturer to the data that they carry. So what I'm going to do here is I'm going to create a broadcast variable called tagdb broadcast, and I'm going to broadcast this tagdb map using Spark context dot broadcast function. So what happens here is Spark basically makes a note that this tagdb map needs to be made available to all the executors in the cluster, right? So that whenever any task within those executors needs to refer to this tagdb map, they should be able to access it locally. They don't need to come back to the driver to access this data. Okay, so at this moment, one thing that's important to note here is that at this moment it's not really broadcasting this tagdb map. At this moment, Spark is just making a note that it needs to broadcast this variable. It will be broadcasted only when there is first access to this tagdb map. Okay. Now we come to this second portion where we are creating a RDD from call drop counts data. When you basically read a text file using Spark context, it converts that the contents of that file into an RDD, which means it's partitioned across the cluster, across different executors, right? So this calls RDD now is a basically distributed data set which contains the data from call drop counts file. Now what I'm going to do in this step is I'm going to enrich the manufacturer based on the tag ID. Okay, so what I'm going to do is I'm calling a map function on calls RDD, which means this function will be applied on every row in that RDD in parallel across the partitions, right? And what I'm doing in this map function is I'm passing on a function called annotate, where I'm also passing the tagdb broadcast variable. So let's see what's happening in the annotate function. So in the annotate function, what I'm getting as input is obviously tagdb broadcast variable that was broadcasted from the driver to all the executors. And I'm also getting every row from the calls RDD partition, right? So what I'm doing here is I am splitting this row on comma, and I know that my fields 1 is tag ID and fields 2 is my count. The first field, that's field 0, was the date, which I'm not interested in. I am interested in the tag ID and the count of calls that got dropped. So I got the tag ID and I got the count of calls that got dropped. Now I need to figure out what's the manufacturer based on this tag ID. And I know my tag ID to manufacturer mapping is present in the tagdb broadcast variable in the form of a map. So what I do is from this map, so basically the way to access a broadcast variable is the name of the broadcast variable dot value. So this content here, tagdb broadcast dot value, is actually a map, a Scala map, right, which contains the mapping of tag ID to manufacturer. So once I pass on tag ID to this map, it returns me the manufacturer. That's the way you access a map in Scala. So my manufacturer is equal to tagdb broadcast dot value, and then I pass on the tag ID to it, and what I get in return is manufacturer. And from this annotate function, what I'm returning is manufacturer and count. So if you see, this row initially contained tag ID and count, and what I'm converting this row into is a manufacturer and count. And how did I get the manufacturer? I got the manufacturer from the broadcast variable, and the broadcast variable was distributed by driver to all the executors, right? So after this map function is applied, basically this RDD, enriched calls RDD, will contain manufacturer and count of calls dropped for that manufacturer, right? Obviously, because you had multiple tag IDs, mapping to the same manufacturer, in this RDD, you will have multiple rows that are mapping to the same manufacturer that basically contain the same manufacturer, and then some count of calls dropped, right? So what we need to do now is we need to aggregate. We need to aggregate all the count of calls that got dropped corresponding to every manufacturer. And the way to do that is reduce by key, because this RDD is a paired RDD. We know that it contains a key and value. Key is your manufacturer, value is your count. So what I'm going to do here is I'm going to apply the function reduce by key, and I'm going to aggregate the values. X plus Y means I'm aggregating all the counts corresponding to the same manufacturer, corresponding to the same key. So in this case, my result now will contain unique manufacturers. For every manufacturer, I'll have the total number of calls that got dropped. Then what I do is I collect this result back in the driver, and then I sort it by the number of calls. Underscore 2 is actually the second value, which is the total number of calls that got dropped. So I'm sorting it by the number of calls that got dropped, and then I am printing everything on the console. So let's see this in action. Let's compile it. Right, and let's run the jar. So when I run it, what I'm going to get is a sorted list of manufacturer and the total number of calls that got dropped for that particular manufacturer over the entire period of data that we had in our call drop counts file. So if you see, Nokia is the worst manufacturer here, which is having the maximum number of calls dropped. Now let me go back to the code once again. So I hope you have understood the concept. Now I have a few questions that I would like you to answer. My first question is there any way to optimize this code a little further? There is one mistake that we are doing in this code. Obviously, we are using broadcast variable, which means the data is going to every executor just once, and then executors can access this data in as many tasks as they need. But there is one optimization that we can do. We are doing some extra work here, which we can definitely avoid. If you want to think about the answer, just pause this video here and then think about it, because in a moment, I'm going to spit out the answer. Okay. So the answer to this question is, think about it. What we are doing here is we are doing annotate on the calls RDD, and calls RDD is the base RDD which contains every raw record from the call drop counts file. So if there are like 100,000 records in call drop counts, you are calling function annotate on 100,000 records, right? Whereas the manufacturer information is required only after you have annotated, after you have aggregated the data at the final step, right? So what you can do is, so what I'm trying to say is, you have multiple rows corresponding to the same tag ID in this in this input RDD, right? You have multiple rows corresponding to the same tag ID. And if there are, let's say, 50 rows corresponding to one tag ID, you are calling annotate 50 times, where every time you are looking up the same tag ID and annotating the same manufacturer, right? Let us say, if you could aggregate the data on the tag ID itself first, okay? You call reduce by key on the calls RDD itself, then you do the enrichment on the aggregated data, okay? Then those 50 rows would have already become one row, right, corresponding to the same tag ID. And you would be calling annotate only once for all those 50 records, which means you will make this annotation 50 times faster, right? And then after you annotate on that pre-aggregated data, you again aggregate. And the reason to again aggregate is because your multiple tag IDs could belong to the same manufacturer, right? You have 50 tag IDs, okay? You have 50 rows with the same tag ID, and then you have another 50 rows with another tag ID. But let's say both these tag IDs belong to the same manufacturer. So you need to aggregate again. But still, it will be much, much faster than this thing, because now your annotation is going to happen on much lesser number of records. Make sense? I hope so. I have another question for which I want you to think about the answer and then write in the comments. Do you think from use case point of view, not really from technical point of view. From use case point of view, do you think this is the right way to figure out who is the worst manufacturer by just counting the maximum number of dropped calls? Think of a manufacturer who just had total 100 calls, okay, and let's say 99 out of those 100 calls got dropped. Don't you think that manufacturer is the worst one? Because 99% of his calls got dropped. Whereas Nokia that we just saw, maybe it has huge number of total calls, and out of the total calls, maybe less number of, percentage wise, less number of calls got dropped. So think about the use case, and maybe from business point of view, this might not be the right solution to the real business question that we are trying to answer, right? So think about how would you really figure out the worst performing devices, whether it's just the total number of dropped calls or whether you would like to look at some other parameters. Okay. So with that, I would uh, end this session. If you have any doubts, please write them in the comments. And just one request, if you like the video, please like, comment, and share. And please subscribe to my channel so that I get motivation to upload more such videos. Thank you so much. Have a good day.